Our next speaker broke his femur, which cut short his very promising mathlete career. So he now tries to protect his data science career more by doing safer activities such as snowboarding and auto racing. Please welcome Joe.
Hello, everybody. Yes. Go for it. Jared, are you the one that set the agenda? I feel like boss is a lose-lose situation. If I do poorly, you're unhappy. And if I do too well, then I upstaged you. Get on with it. All right, I'll use the arrow keys. Okay. So obviously, I work for Jared. I'm a data scientist, so this presentation is going to be a bit of a boots-on-the-ground approach to a specific topic. I also work as a research scientist at NYU, so hence the kind of disheveled look compared to our other presenter. So today I'm going to talk about GitHub Actions. And I apologize if this kind of appears as an ad for Microsoft, because it's a bit of a love story. But before I get into it, I think any data scientist, there's a few pivotal moments in your learning process. You come across certain tools, like say R or Python, excellent scripting languages that enable so much to do. ggplot2, the great package that allows visualization of your data and so much more. And then Shiny, a really powerful web framework for building these interactive web applications. And then finally, coming from a statistics background, just statistics and ML, all these different algorithms that allow you to help predict and explain the world around us. But I want to add one more thing, which is GitHub Actions. So what is GitHub Actions? Well, imagine you have computing power. I like to call this, the Raspberry Pi in the sky. This is easy to use. It's free in many cases. You can scale up and start paying if you'd like, but it's excellent to begin with. It's at your fingertips. It's easily accessible, and you can set it on a schedule. It's automatable. It's schedulable. You can set it up so when you push your code, it executes right then. And finally, it's no to little maintenance. So how would you use this? Well, just like a Raspberry Pi, there's almost an unlimited amount of opportunities to use it for. But most people use it for doing what I think is kind of boring things. Running unit tests, checking package code, deploying packages. These are all really useful things. They're actually, exceedingly useful and have changed industries. And is what CI/CD is for. The talk about this is, CI/CD. CI can do more. And there's just more to CI/CD than just this. So it's all a bit uncreative, all a bit boring. But, sometimes boring things are good. In the R ecosystem, there's a great community around GitHub Actions. Here, we have a YAML file, and you can kind of view this as the instruction set for GitHub Actions. So all these are kind of various steps that do something for you. This one here sets up an R environment. So like a Raspberry Pi in the sky, you get a blank machine that does whatever you want it to do. Here, it installs R, and then you have to do what you will with it. And there's various other, scripts, YAML files that do things for you. Set up R environment, set up packages. If you're using RM in the R world, that does it for you. Here, we check an R package. These are all things, you don't have to write this yourself. You pull this off the community, and it does it for you. So these are very useful. They're pre-canned. It's not just R. There's equivalents in many other languages. And what that workflow looks like as a developer is something that people are already very used to. So you code, you commit your code as you do with your repo, and you push that up to GitHub. And really the magic is things that you don't see. Once you have this set up, it executes for you. So every time you push, you can have it, so it executes code. So imagine you write an R package, you make some changes to that R package, you commit that, you push that up to GitHub. GitHub Actions sets up a machine for you, installs that R package, runs those checks, and you either pass or don't pass those checks. That's kind of a traditional CI/CD approach. But like I said, it's kind of boring. There's many more things that you can do with GitHub Actions. And really, it's up to you. So one good example that we often use it for is pulling down API data. So imagine you need to source some data from somewhere, be it weather data from Open Weather. You need every single day pull down weather for, say, Tampa, and then store that in your own database for use later on. You could also hit financial data, you hit OpenAI API, whatever API you'd like. As long as you can write a script for it, you could access it. You can do it for more traditional things, but I often list this because many data scientists don't do this. You could deploy dashboards. So you build your dashboard, you commit, you push, it passes your checks, and then deploys it to somewhere like shinyapps.io or your own server. But today, I want to show you something a little more unique. You can actually use GitHub Actions for refitting models, originally fitting your models, and then also scoring your data. And you could score it however often you like. You could set it on a daily basis, a monthly basis, an hourly basis, whatever works for you. So here's a problem you may face. Imagine that you just built a great custom forecasting algorithm to predict the next 30 days of sales. You've already done all the hard work. And like Jared said in the last talk, this is pretty in-depth, right? So there's many different steps to this. One, as a data scientist, you're probably familiar with. The first being sourcing your data, hitting APIs, going out to the outside world, getting data where you need it from. Cleaning that data. That's often 80, 90, 95% of your work as a data scientist. Setting your exogenous variables. So these are your predictors. Fitting your models. So going through, for forecasting, ARIMA, auto-ARIMA, GAM, profit, RNNs, anything that you want. Remember, this is custom. This is you writing these scripts, getting it done. Cross-validating all those models, so ultimately you can get to the point where you pick the best one. Setting your evaluation metrics, RMSE, MAPE. Again, choose whatever you like, given your background and expertise. And then finally selecting that best model and making forecasts from that best model. Nothing unique here. If you know forecasting, this is probably a relatively standard approach to building an algorithm. And perhaps you wrap this all into one .R script or a .Python script. So this is a lot of work done so far. So pat yourself on the back. This probably takes weeks, months, quite a bit of time. But you really haven't addressed probably your core business organizational problem, which is that you need to continuously predict the next 30 days of sales for it to be useful to your business. So how can you get that done? Because really what you need to do, you need to run it most likely every single day, and with that you get model drift. Your model just isn't as good, today as maybe it was yesterday. To address this, of course, you need data every single day. You need to score it every single day. And then on some regular cadence, say monthly, you're going to have to refit that model to address that model drift. So I'll give you a basic blueprint as to how you can do this with GitHub Actions. First, instead of just having one script, structuring this in a little more formal way. And one way to do this is to have a few different scripts. So you can imagine one of my early steps, getting data, that would be one script. Another one would be training. Another one would be scoring that and making those predictions. Now this is really up to you as to how you like to structure your project. And Jared mentioned a great thing in the last talk, targets, which I'll talk a little bit in a moment about. But generally, you want to have a more decoupled approach to your project. And here's really where the magic comes in. I showed those YAML files earlier. These YAML files are really the instruction set. GitHub Actions relies on these YAML files, and what you'll see here is that this would live in your repo. So we have, at the top, you see it says .github workflows update weather. That's the directory that it would live in, and GitHub itself knows to look in here and execute these files here. So we give it a name, pull weather data from our API, and we say, okay, here's one job that we have. We're going to call that update weather. And the first thing that we're going to tell it is we want to run this on a Linux machine, Ubuntu running 22.04. And from here, we're going to start adding steps. So our first step, which is the most common that you see pretty much in every single YAML file, is that you check out the repo. This is just saying, okay, machine, now you have Ubuntu. After you have Ubuntu set up, the first thing you need to do is pull down the repo itself and have that code available to you. And from here, since we're going to be running a .r script, we're going to use a community file from the rlib actions called setupr, and it's a v2 version. And what this does, it goes out to the internet, downloads R, installs it on our new Linux box. And here we're telling it, install 4.2.3, because that's what we use with our project. And then let's keep going through these steps. And it's actually very simple here. We only have 3. We checked it out, we set up R, and then finally we just say, okay, source our script. So in the previous, we had our getData.r, and we had our train.r, and we had our score.r. Here, we're just going to say set up and run our getData. So we execute that, but we really haven't done anything that special here. We have our machine, it executed it, but it's not really helping us because it's not scheduled. GitHub Actions makes this really easy to schedule. Here we have cron syntax, so it may look funny if you're not familiar with it, but all it's saying is run every day at 3 a.m. And that's basically it. This is 19, 18, maybe less with comment lines of code, and very, very simple, very straightforward. But there's really even more features that you can do. We specified Ubuntu on the last, but you could use Mac OS, you could use other flavors of Linux, you could use other versions of Ubuntu, and of course you could use Windows if you prefer. You can also, like we showed, schedule it, but you can also do on demand. So every time I push the code, I can have it execute then. And for free, GitHub gives you, I believe, 3 or 4, it's 7 gigabytes of RAM now. They've been upgrading it, 7 gigabytes of RAM now. And I think a dual core processor, which is fine for fitting many forecasting models on a moderate amount of data. But for many use cases, that probably won't be enough. So of course, you can cough up a little extra cash, and they'll give you a more powerful machine. And there's a great community around this. R, the steps that I was using, uses the rlib libraries, but there's a whole community around different types of languages. And what I want to leave you with is, Jared talked a little bit about targets, about kind of having a DAG, a directed acyclic graph approach to how you structure your code. This can really enhance how you build your GitHub Actions pipelines, because with just having 3 files, that get data, that score, and those train files, that can get messy. So what DAGs do for you, and in the world of R, targets is a great package for this. And here's a short example. So imagine in your project, you have a handful of different functions and different files that you're using. Here we have plot model function, a get data function, a fit model function, and then some data maybe from a file, and they interact in this way. But you can imagine as you're working through this and you're executing it, some things become out of date, and you don't want to run everything all again. So one of the main features of targets in this DAG approach is that it understands which data and which files are out of date, and when you reschedule or rerun this, it will only run what's needed. So in this case, plot model is now out of date because it's light blue, and if you reran this whole pipeline, then it would only execute plot model and the plot function, which it's dependent on. But there's many other pipeline tools available, not just R and targets, and you can find these on the link on GitHub. So what did we cover? We covered GitHub Actions is just computing power. It's a Raspberry Pi in the sky. That's easy, it's cheap, it's at your fingertips, and it's automatable and schedulable. And you can do whatever you like with it. You can pull down API data, you can refit models, you can score models. And so it's really up to you as to what you'd like to do with it. And with that, I will end a little bit early because I think I'm holding everybody up for lunch. Thank you.